Chapter 2, Atomic Structure, Bohr's Atomic Model. Okay, so let's look at what we need to focus. Okay, first of all, it says that calculate energy of an electron at. So when you look at the word at, you must use this formula. And then the final answer must have negative sign. Calculate wavelength, and then you must take note it is in nanometer. Okay, then energy and also frequency. Okay, so in this case, what I want to highlight is, remember, when you use this formula to find wavelength, the final unit is actually meter, not nanometer yet. That's why you have to convert it to nanometer. Okay, so that's all for this one. Okay, let's look at sample exercise number 3. The one that I want to highlight is actually the sentence. Okay, when you see the word excited, you know energy is absorbed. Therefore, the energy is positive. Okay, if it drops, falls, or transferred, then it must have the sign negative. Okay, now let's look at how to determine initial and final. Okay, from. From means this is initial, to is final. So you must know how to differentiate initial and final. Okay, from n equals to 2, from, and then to 1, final is 1. Okay, why must we know how to determine initial and final? Because we want to substitute into the formula expression. Okay, and remember, for energy, your Ribot equation must use 2.18 because the unit has joule. Okay, now next one. When you are given a series, okay, for example, P1 series, then you must know the clue given is electron will drop to a lower level, that is n equals to 5. And then be careful of the question because the wavelength is given nanometer. Okay, when it's given nanometer, why do we have to take note? Because in the calculation for Ribot equation, the Ribot constant unit is meter per meter. Therefore, when we substitute into the expression, we also must use meter. Okay, now next one. For the Ribot equation, remember you must use N1, N2, not initial, final, and you must label N1 less than N2. Okay, and then one thing that students always overlook is also calculation part. This is 1 over N2 squared. So later you have to square root your answer. After that, remember to label the answer. Okay, now another one is explain. Okay, explain, you have to explain one by one until the end. Okay, absorb energy, jump to higher energy level, excited state is very unstable, drop at midnight in the form of photon. Okay, now in this part, I just want to highlight how to find the information faster. The lower level and the higher level. Okay, bracket series, we know that electron will drop to n equals to 4. And it already mentioned second line. Okay, if second line, I would straight away 4 plus 2 equals to 6. So I know the higher energy level will be 6. Okay, or else you can draw the energy level diagram 1 by 1. N equals to 4, n equals to 5, n equals to 6. Okay, another one is line spectrum. Line spectrum, the most important thing is identify the first line. Okay, how to identify the first line? If you see it has the longest distance or spacing, then the line here will be the first line. Okay, so we are done for the first line. Another one is we have to know which series is this. Okay, now we look at this important clue. Red light. Red lights mean visible. Visible means it is in Balmer series. Balmer series means that electron will fall to n equals to 2. Okay, therefore you see, I just imagine that this line is lower n equals to 2. So if I have first line, the higher level or the excited level will be plus 1 and so on. Okay, so I have 3, 4, 5, 6, the higher level. Okay, now let's look at the terms. Okay, student tends to mix up with the terms. Electron transition, you have to give sentence. electron drops, falls, or transits from. Okay, draw the electronic transition on energy level diagram. This is the energy level diagram, okay, which you must give unit as well. Okay, then another one is line spectrum. This is line spectrum. Okay, now let's look at this. Okay, I give you two pictures to compare because usually students make the same mistake, that is all the energy level has the same spacing, so it is incorrect. Line spectrum all has same spacing, also incorrect. Okay, so remember the gap is getting smaller when going up, and then the first line, the spacing must be the largest. Okay, this one has no problem. Okay, another one is identify, is it shortest or longest? Remember, the one that has the largest spacing will be the longest wavelength. Okay, first line longest, therefore this will be the shortest. Okay, another terms that you have to remember is ionization energy. Ionization energy, the final unit must be kilojoule per mole. Okay, so for kilojoule per mole, remember what we are calculating here is only for one electron, not 1 mole of electron. Therefore, in order to get kilojoule per mole, you need to multiply by Avogadro constant. Okay, and remember it must be kilojoule per mole, not joule per mole. Okay, so summary. If you look at the word energy at, you have to use this formula. If it's a transition, okay, then you have to use the energy, see the changes sign, and then we have infinity sign, infinity and level 1 for ionization energy. Okay, for wavelength, you can use Rydberg equation, but remember to label N1 less than N2. And be careful of the Rydberg equation because we have two Rydberg equation. One is for energy, joule, one is for wavelength, meter. Okay, so okay, now this one is for the and how to draw the energy level diagram. Okay, remember this one. Okay, when it's infinity, the line tends to be very close together. Okay, so and then another one you can see here, if it is the first line, okay, if it's the first line, you will have the longest wavelength here, and then this one will be the convergence limit here will be there will be smaller or lower, shortest wavelength. And remember all the series, okay, and all the region. Okay, so that's all for this part.